Hi guys, Major Frenchy. Welcome to my brand new video. This video is dedicated to the Oak Micros Pinscape All-in-One. What is so special about this board? Well, I've tested a lot of solutions out there. I've tested the SaintSmart, I've tested the LED Wiz, I tested the Pack Drive, and none come even close to this. Why is it so nice? Well, first of all, it's all in one. That's all you need for connecting all your force feedback and your LED in your virtual pinball cabinet. By the way, I do not get compensated for this guide, nor do I get paid for this. So let's just look at this video. There's going to be multiple parts. The first one is the introduction of the board. Then I'm going to have a PowerPoint explaining all the connections. And I'm just going to show you basically on my cab how it looks. So for people that are wondering, what the heck are you connecting on this board? What is it for? Well, you connect all your buttons, you connect all your contactors, solenoid, your fan, your shaker motor, your LEDs, your chime unit, your gear motor, name it. Everything that you have on your cabinet, it's going to be on this, which makes it very, very nice. This board works along with the KL25Z, which is the small board you see at the bottom right. All right, let's just zoom in on that board and see what these ports are for. So the first bank that you're going to find is the buttons input. So it's from 1 to 8 over here. And then we'll switch side. And then you have 9 to 24. So 24 buttons input. So basically that's the signal wire from your buttons that you will basically just connect here. And actually I like this board because it makes it easy. You can start by wiring all your stuff, right? Just like connect your buttons. When you're done, you can just clip it in. And you're done. So the other bank that we find here, you can see it's indicated on the board. High power outputs, and then we have 32 outputs. We got 16 here, and we got 16 over here. And it's always indicated on the board, so it's difficult to be mistaken. What that is, it's basically where you're going to connect all your toys, your high power toys. What I mean by that is your solenoids, your contactors. And why does it say high power is because you can see here there's a bunch of MOSFET, there are transistors, and this is designed to boost power. So you've probably seen in your research that you need power booster for these devices. Well, this is already built in this board. Moving along, on the other side, you can see here chime output. So we got 8 ports. So these 8 ports, it's for your chime unit. You can see right next to it, there's the knocker. So you got knocker right here. This here, I'm not going to use, but you can actually have your TV infrared connected to this, so all your devices are starting at once. Then we have, here you can see you have your strobe, you have your RGB flasher, you have... So basically here is your 5 LED flasher bar. So this is really cool because see you got 1 red, 1 green, 1 blue. 2 red, 2 green, 2 blue, 3 red, 3 green, and so on. 5. So we got 15 ports right here for your 5 flashers. So everything here is run via USB using the KL25Z, which is this development open source board. And you connect that port to your computer, and then it's powered. And then this will even have 3.3 volts provided by the USB. Now over here is the plunger, and then you have the signal, it's called a wiper, 3 volts, and this is the ground. Another board that we're going to use from Oak Micros is this fuse board. It's cheap. Actually, it is cheaper than if you build your own. Trust me on that. What you will do is you connect your 16 fuse on here, right? One side is the input, the other side is the output. Solenoids, right? I got 10. And then my knocker, my chime, my gear motor and shaker motor. So here's the guide I created to connect all my force feedback and LEDs to the Oak Micros Pinscape All-in-One. So the All-in-One basically is a complete solution for connecting all your devices inside your cab. It has 24 input buttons for everything like flipper buttons, a tilt bulb, for example, to make it your table tilt, so you can connect that as well. The KL25Z has the accelerometer built in. There's also TV remote, so you can connect all your IR from your TVs to the Pinscape, and it will turn it on or off. There's 16 LED output for 5 volts, 16 LEDs output. That's for your small LEDs. There are 32 MOSFET power output for driving higher power devices such as contactors, shaker motor, and fans, and so on. There's 9 MOSFET for power outputs, and it has a KL25Z built in. So let's just start with powering up the Pinscape. There's going to be 5 volt and 12 volts and ground going to this board. So let's just get into the meat and potatoes of it. So guys, you're going to need, right off the bat, you're going to need at least 2 power supply, or it is actually not recommended that you use your actual PC power supply for this. Get an external power one. And you're going to need 12 volts and 5 volts for this. And also get yourself some terminal blocks. That's going to be your central ground, and then you're going to see all the grounds go to that central ground in here. So let's just start with the negative. So we're going to get the negative from the 5 volt power supply. We're going to send it to the central ground. We're going to do the same thing with the 12 volt power supply. And then we're going to actually take care of the ground for the 5 volt on the board. So if you look on the right side, you're going to see the overview image in the middle of where these ports are located. 5 volt ports, they're at the bottom left. The 5 volt and ground on the left bank. So you connect one ground here, and then you connect a second ground to the logic 5 volt ground. Next, you're going to need also to double up your ground for the 12 volts. So it's just for balancing the load. It is actually recommended that you double up. So 2 wires. So that's why you got 2 pins. So 2 grounds going from the ground to your central ground. You're also going to connect the 12 volt V+ from the power supply to the 12 volt port on the board. I'm going to describe the layout of the button. There's the ground pin that you see. Then there's the signal that will go to your button input. There's the cathode and the anode, which is the power for the LED. Now we're going to connect the V- from the power supply to the central ground. Then we're going to have the ground from the button pin micro switch to the central ground. Then we're going to have the cathode from the pin for the LED holder to the central ground. And the anode is going to go to the V+ of the power supply. Now, if you wish to connect the button on the Pinscape all-in-one, you need to send it to the button's input. Take the connector on that signal pin, and then you send it to one of the port on the Pinscape all-in-one. There are a few buttons that are actually managed by DOF. For example, the coins, you've got the start, you've got the launch. So these buttons will light up at different times in the sequence when the table is launched and whatnot. So for that to happen, you're going to have to connect your button on the Pinscape. You connect the cathode of the LED to the RGB port on the Pinscape. We're going to connect the shaker motor. This one is a Stern shaker motor, and a 12 volt power supply will be required for this. We're going to connect the positive of the power supply to the positive side of the shaker motor. And we're going to connect the negative side of the power supply to the central ground. Then we're going to use a diode just to prevent the current from flowing back. We're going to connect the negative side of the shaker motor to the cathode of the diode, and the positive side of the shaker motor will go to the anode side of the diode. And we're going to use a 5 amp slow blowing fuse for this. And then we're going to connect the cathode side of the diode to the fuse, and the other side of the fuse will go to high power outputs on the all-in-one. Contactors are a great addition to your cab. This specific model sounds great. To connect this, we're going to use a 24 volt power supply, and then the positive side of the power supply will go to the positive side on the contactor, which is labeled A1, and we're going to connect the ground from the power supply to the central ground. We're going to use a diode again, just to prevent the current from flowing back to our board and making some damage. And we're going to connect the negative side of the contactor to the cathode side of the diode, and the positive side of the contactor will go to the anode side of the diode. Then we're going to use a 1 amp slow fuse, and then we're going to connect the cathode side of the diode to the fuse. And the other side of the fuse is going to go on a port on the high power outputs of the all-in-one board. Connecting a strobe is easy. Most of them work on 12 volts. So we're going to connect the positive side of the strobe from our 12 volt power supply. And then we're going to connect the ground, the negative, on the 12 volt power supply to our central ground. Now we're going to connect the negative side of the strobe. Is going to go directly to the port labeled strobe on the all-in-one. As you can see on the picture on the right side, this port is located at the bottom left of the Pinscape all-in-one. Next is the 5 flashers for your flasher bar. Now, I wish I would have known about this flasher before I started my build, because man, it saves so many steps, and it's actually an all-in-one. It's a 12 volt flasher with a resistor built in, so you do not need resistors. So it's great. It's from our friend Arnoz. I'm going to have a link in the description below as well. Along with the Oak Micros board, you're going to connect the 12 volt of your power supply to the 12 volt wire labeled on the flasher. Then you're going to connect your negative of your power supply to your central ground. Then what you're going to do is you're going to connect the red, the R, on the actual flasher, all the way to the 1R on the all-in-one board. If you look below, it's actually on the bottom left of the board if you want to find this port. Then we're going to connect the green, and then we're going to connect the blue to a different port, and that's it. So 1R, 1G, 1B, and then you're going to connect all other flashers in sequence, and you are set. Here's an example of a 5 LED flash bar that's found on a system. It consists of 5 plastic dome with RGB LED underneath, which I'm going to show you next, and the color changes based on the table script. So we're going to start with a 5 volt power supply, and then we're going to connect the negative of the power supply to the central ground, and the positive of the 5 volt power supply, we're going to run a line next to the LED. And then we're going to need to run a line for each tab, because each color needs its own power. Then on the other side, we need to put resistors, otherwise it's going to blow. And the resistor that we're going to use is for the red is going to be 8.2R. Then we're going to connect the red cathode to the one side of the resistor, and the other side is going to go to the 1R port on the all-in-one. And as you can see on the small picture on the bottom right, the location of these ports is at the bottom left of the card. Now we're going to do the exact same thing for green, except the value of the resistor will be different because the power is different for green and blue. So this one is going to be a 5.6R for the resistor, Then you're going to connect the green cathode to the resistor, and the other side is going to go to the 1G port. And then the same thing for the blue. We're going to have the same resistor, and we're going to connect the one side of the resistor, and then the other side is going to go to the 1B side of the all-in-one. Now, if you wish to get an all-in-one solution, Oak Micros has its own resistor board, which makes it easy for you, and it's fairly cheap. The principle is the exact same, except the resistor are already on the board. And you're going to see, I'm going to show you the connection right now for it. So we're going to start with the power supply, still using a 5-volt power supply. We're going to connect the negative to the central ground, and then the positive of the power supply, we're going to run next to the LED, and then each tab corresponding to the color. So this one is for the red, one for the green, and one for the blue. Now we're going to connect the red cathode to the first port on the resistor board, which matches that blue resistor, which is a 8.2R. And on the other side, there's a matching port number 1. That's going to be the output. And then you're going to connect to the 1R port on the all-in-one. We're going to do the same thing for the G, except the G is going to connect on port number 2. And as you can see, port number 2 is linked to resistor, the gray color, and it's 5.6R. And the opposite side is going to connect to the 1G port on the all-in-one. And finally, the blue, we're going to connect to the third port. And again, the blue resistor value for that connection is gray, which is the 5.6R. And the other side is going to connect to the 1B port on the all-in-one. Now we're going to connect the beacon. We're going to start by connecting the negative side of the power supply to the central ground. Then the 12-volt positive of the power supply will go to the positive side of the beacon. Then the negative side of the beacon will go to a 2-amp fuse, and the other side of the fuse will go to a high power outputs on the all-in-one board. Now let's get into the plunger. I have videos about plungers. There are different models, but that's the one I'm using. It's the Oak Micro Plunger Kit, and it's labeled. You can see at the top in the picture where it says 3.3 volt ground and wiper. There's a connector just above it. That's where you're going to connect the wires. So we're going to just start basically very straightforward, guys. The ground on the all-in-one Pinscape, you're going to run a wire all the way to that ground pin on the plunger. Then the wiper that marked INT on the board, you're going to send that to the wiper pin on the plunger. And finally, the 3.3 volt goes to the 3.3 volt pin. Now, once you're done, you're actually going to connect that KL25Z to the computer just by connecting the provided USB cable, and it's that port right here that you need to connect. The other one is to program or make some modification on the KL, but for USB, for using with your pin cab, it's the port that you're going to use. Now, some of you may have chimes. They're actually a good addition, and they make a lot of noise. So how do we connect those? Same principle, guys. We're going to use a 24-volt power supply for this, and then we're going to have the ground from the power supply to the central ground. So we're going to use the positive side of the power supply, and then we're going to run a line along the chime unit, and then we're going to actually use the positive to each positive terminal of the solenoid that's basically pushing the bar. And we're going to have 3 diodes, guys. And we're going to connect the positive of each positive terminal to the positive side of the diode, as you can see on the diagram, okay? And then the negative will go to the other side of the diode. We do that for all 3 of them. And then once we're done that, we're gonna use 2 amps fuses. You need 1 fuse per bar, okay? So basically per solenoid. And we're gonna run, again, The negative of each diode will go to the one side of the fuse, and the other side of the fuse will go to a designated port that's basically marked 1, 2, 3, 4, 5, 6, 7, 8. They're on the top left of your Pinscape All-in-One. They're for Chime, and I believe it's marked on the board. It says Chime. We do the same thing for the second solenoid and the third solenoid, and we are set. Now here's a little addition for you guys. I had a few requests. People asking, how do I connect the Oak Micros Pinscape Lite? Well, here it is. I'm going to show you the different connections, but it is very similar to the all-in-one, guys. It's just a smaller scaled version of the Pinscape All-in-One. So the board consists of 64 screw connectors that are found in banks of 8 ports around the board. If you look at the top, you're going to connect the 5V plus from your power supply to this port, then a ground from your central ground to that port, another central ground to this ground port, and a 12 volt V plus from your 12 volt power supply. Now there's also 24 buttons inputs, and you're going to find them on the where the KL25Z USB ports are, and one extra just at the bottom right of the board. Now there's also 12 MOSFETs power outputs. Now these are for contactors, solenoid, shaker, gear motors, beacon. So anything high powered, that basically provides you the boost it needs to trigger these devices. So, and you can find them at the top of the board. There are 2 banks of these connectors. Also, there's 16 RGB outputs. Now these can be used for your flashers. There are 2 banks that are found on the left side of the KL25Z. So I have everything connected, everything tested, and it works like a charm. I'm so happy. I spent so much time doing all the setup and all the wiring and all that, and I'm actually quite happy with the end result. It looks clean. The wires are hidden in those tracks. Those tracks actually are really handy, and it works really well. So let's get to the Pinscape. Now I described all the connections, how everything worked. So now this is, well, real life scenario. So I have the fuse board. So I have different fuses in here. I mounted my fuse board next to my Pinscape All-in-One, and I'm just clipping the fuse in the different holders. This is my chart that I wrote. It's a big time saver, especially when you're doing the DOF config. You don't have to look around all your devices. It's all here. Okay, so number 1 here. So it goes to here. Now I got them disconnected because I want to show you when you're testing your devices. I like to test them without actually using the board first, just to run like a dry test. So everything that uses power will get disconnected, and we're going to test, and I'm going to show you how to do it. So here is actually the buttons. So the buttons are connected on these ports. This is the power for the board, right? This is the 5 volt, this is the ground, and this is the ground and 5 volt as well. It says right here, right? And then there's a 12 volt input. The 12 volt input is right here. This one right here. You double up, put 2 12 volt wires, and then the 2 next is the 2 grounds. Also double up the 2 grounds. It just helps with the balance of the current. And this white one here is my knocker, just connected here. And these right here are my chimes. So they're gonna go, see, it's marked. So 1, 2, 3 are my chime. So, all right, I'm going to show you how to test this first without having the actual board connected. So it's very complicated to test. You need a lot of equipment. No, I'm just kidding. You need gator clips and a small nail. That's it. So I'm just connecting the gator clip on my ground. So this is my central ground, like where all ground goes. And here is my little nail. And all you gotta do is you touch the appropriate port and it will get triggered. So that's why I don't do it while it's connected on the board, right? I don't want to kind of mess up with it. So here's the first one here. So that's my left back. This is actually this guy right here. Second one. So that's the tiny guy right here. That's my middle back. I like different noises, so that's just me. And the third one will be the back right, which is this guy right here. All right, number 4. That's my center left. Center middle. Center right. And here's my funny little flipper. They're really quiet. Look, listen to this. So when I hit the flipper, that's all I'm going to hear. But that's all I want to hear. So depending on what you want, like, you know, you set it the way you want. So the first one here. Oh, that's my left bumper. Right bumper. And next one. Oh, that's my powerful fan here. I got it on 24 volts. Next one. Oh, that's my beacon. I got them on 24 as well, so they spin a lot faster. This is my gear. Next one. Oh, that's a shaker, I would assume. This board allows you to module the current, so which means you can, in DWF, you can set it to like 40% intensity or 30 or so on, and it will adjust the value of the shaker motor without having the dial. Remember, I had a previous video where I was using my dial. Well, you don't need that with this, so that's kind of cool. All right, here I got my 3 chimes. So that's cool. And this is my knocker. So I've got all my stuff working. So now I can just reconnect. Just reconnect everything here. There you go, you got this. And then reconnect. So this is for the flasher. So this is outer right. I got the red, green, and blue. Now I hope you guys found this interesting. It was actually kind of worth it doing this because I'm sure it's going to help a lot of people. The software is going to be a separate video because there's a lot to the software as well. Not as much as the hardware, but there's some stuff, and I didn't want to cram it right in the, like in the same. So I'm going to do a separate video for this. That's going to come out in the next couple of days. Also, all the links for the Pinscape All-in-One, the Arnoz RGB, and some other stuff that I've used is going to be listed in the description of the video below. Also, guys, if you want to join us, a lot of us are hanging out on the Discord virtual pinball chat. That's where we hang out. That's where we share our ideas. Actually, Mike from Oak Micros hangs out in the Discord as well. So come and just say hi. And so I hope you guys enjoy this, and I will catch you in the next software video.